The objectives for this video are to learn how to construct a confidence interval estimate for the population mean and to learn how to calculate the margin of error for a confidence interval estimate. The Arctic sea ice extent measurement for a sample of 37 days showed a mean of 11.9 million square kilometers and a standard deviation of 0.4 million square kilometers. The sample mean of 11.9 million square kilometers is called a point estimator for the population mean. The problem with point estimators, like the sample mean, is that they can be unreliable due to sampling error. The population mean at a given point in time is a fixed value and would reside somewhere on the number line. When sample data is gathered and a mean is calculated, that sample mean may be slightly smaller than the actual population mean, or it may be larger than the actual population mean. It is impossible to know exactly where a sample mean lies in relation to the population mean unless the population mean is actually known. When the population mean is not known, we will increase the reliability of our estimate by constructing what is called a confidence interval estimate that will be centered at the sample mean and surrounded by a margin of error. We would begin by calculating the sample mean. We would then add the margin of error to the sample mean, and then subtract the margin of error from the sample mean. So our interval would assume the form x bar plus or minus e. The margin of error when calculating a confidence interval about a single mean is determined by three factors: a t-value, the sample standard deviation, and the sample size. The t-value is taken from a distribution known as the student t-distribution. This table shows an excerpt from a table of t-distribution values. Note the abbreviation in the left column, df. This refers to the number of degrees of freedom. For this application, the number of degrees of freedom is one less than the sample size. Note the top row gives varying confidence levels. The highlighted example would be for the construction of a 95% confidence interval with 21 degrees of freedom. Let's construct a 95% confidence interval estimate for the population mean Arctic sea ice extent. Certain assumptions must be made when constructing a confidence interval estimate for a population mean when the population standard deviation is unknown. The first assumption is that the sample is a random sample. The second assumption is that either the sample size is greater than or equal to 30, or the population is normally distributed when n is less than 30. So we will calculate the margin of error and add it to and subtract it from the sample mean. Recall that the calculation of the margin of error requires the use of a value from the t-distribution. Our confidence level is to be 95%. The number of degrees of freedom will be one less than the sample size, so 37 minus 1, or 36. So we will examine the table and look across the top row for our 95% confidence level. So this is the column that we will get our t-value from. Now we will drop down until we find 36 degrees of freedom and find out where that crosses up with the 95% column, and we have a value of 2.028. So we will calculate the left and right endpoints of our confidence interval by substituting the sample mean, t-value, sample standard deviation, and sample size. The resulting interval endpoints are 11.8 and 12.0. Our interpretation of this interval will be stated as follows. It can be stated with 95% confidence that the population mean Arctic sea ice extent is between 11.8 and 12.0 million square kilometers. In this video, we learned how to construct a confidence interval estimate for the population mean and how to calculate the margin of error for a confidence interval estimate.